My name is Tommy O'Brien. I'm a graduate student at the Micro and Nanotechnology Labs at the University of Illinois in Urbana-Champaign. I work for Professor John Delasasi in Photonics and Integration, and I'm currently working on a project with Professor Clara Narstedt at the Coordinated Science Lab, a grant from the Data Infrastructure Building Blocks through the National Science Foundation to provide real-time data curation and coordination. So the idea of this project is to provide a way to collect data real-time from scientific instruments such as a scanning electron microscope or a transmission electron microscope or atomic force microscopy, and share it with the rest of your group and your advisors or potentially other collaborators at across groups or across universities. And the reason that a piece of software like this is needed is the current way of collecting this data is via a thumb drive or trying to use Box or Dropbox. And when this happens, when you export your images, you're really just getting a PNG file, and there's much more to that image. What's happened to your sample before it in terms of processing, and the camera settings itself on the SEM or the TEM. If you want to reproduce that same picture, you'll need that sort of information, and all of that is lost as soon as you have to export from its native proprietary software and move around on a thumb drive or some other file sharing system. Okay, so this is what we're referring to as the Curator. It's really just a web app that looks sort of like the web front for Dropbox or Box. And the way it works, I'm looking at the tree view currently in my dashboard, and I find this the most intuitive because it looks very much like File Explorer in Windows or Finder in Mac. And everything is just a series of nested folders. And the way that ForeSeed works specifically is that files can only live inside a container called a data set. And these data sets, you can group them together based on experiment or sample number or processing run number into a collection. And these collections can hold many data sets, many other collections, just sort of like a normal file tree. The spaces mechanism is a container that can hold data sets or collections, but it's what's used to share those files out to group members, advisors, or collaborators. And I'll talk a little bit more about spaces specifically later. Okay, so I'm going to look as an example at our ForeSeed examples collection here, and it has underneath it a sub-collection, just called test sub-collection, and also 3 data sets, each of which has a handful of files inside. So each one of these data sets came from one unique upload. So if you were working on a sample and after, say, a dry etching process, you wanted to look at scanning electron microscope and take images, you would upload all of the images you took as one data set. And I'll look in here as an example just to show you both how that works and how extractors work inside of ForeSeed. So this would be an upload I did at a tool, in this case the transmission electron microscope. We can name the data set here. This is just a demo for extractors, describe it a little bit where I just repeat myself. And then what we have here is a DM3 file, which is the proprietary file format for the software that runs a transmission electron microscope. And even though it's a proprietary piece of software, what we see here is a preview image, which is analogous to the type of image that would have been exported from digital micrograph when using the TEM. But we don't need a copy of the software here to do that. And then for me, that's part of the beauty of ForeSeed is it has a handful of built-in extractors that can create preview images of proprietary file formats. The same thing is true here for AFM. This is an Igor file format, and we can find a handful of different extractor images based on this sort of file format also. Okay, in addition to the extractors that run that are able to pull out metadata from the imaging, like transmission electron microscope or SEM sort of metadata, what the camera settings were, accelerating voltage, probe current, we can also append user-defined metadata as we upload the files. So in this case, when we uploaded the gold-filled micelle image from the TEM, we also had a handful of user metadata that we thought were important to be attached to this image. In this case, it's a lot of the prep work for the sample to look at in the TEM. Incubation time in minutes, this case just 1 minute, And this is any sort of key value pairs that you want to add can be added. And when we look at the uploaders, I'll look specifically at how to define that metadata, either freeform or through a template that you might want to define for your group if you do a lot of the repeated experiments on the same sort of samples. Okay, so moving on from the web-based curator, what we want to look at is the uploaders, which is specifically what would be run at the tool when you're collecting the data from the SEM, the TEM, AFM, XRD, anything like this. So this is the interface that it looks like, and it's sort of a three-step process. The first thing you do is decide if you would like to place your data set that you're collecting images for in a shared space. If you've already created a project space that you're sharing with your advisor or with your group members, then you would just hit yes. So in our case, I want to do this. If you look, I don't have a shared space for what I'm trying to do. So what I'm going to do is create a new test space. And our name would just be test space for DIBBS demo. Description is just a test description. We can type usernames here if you want to give them access to this space immediately. We can also just do this later through the web interface if you don't want to waste time at the tool. And I will opt for that because I don't like paying money to manipulate software. So we'll just create the space. We want to put a collection in. There's no collections because we just created this space, so we'll create a new root collection. This is just our test root collection. And any example description here will work. Create this. So step 2 then is to choose this collection, is to put a data set into this collection. And remember that the data set is just the folder that holds a bunch of images. Or really any file type, but in our case, this will be images. So we obviously don't have any data sets. This is where we choose a template, like I had said before. So we can either go with the basic uploader route, where if you're in a hurry, or you're just putting the data temporarily in ForeSeed and you don't much care about the cataloging and curation of this data, you can use the basic, choose a simple name, and you can put in your user-defined metadata like we looked at before, in sort of key value pairs, just comma separated. A better way to do this would be to use a template. I have a handful of templates here that I've made, so we'll just choose one, dry etching, and you see it has a bunch of key value pairs with your dielectric deposition tool. Maybe in our case, this is a Trion, and a bunch of sort of etching. What's being etched? What's your mask? What gases are you using? What's the pressure? When you create a template, you can make the fields required or not required. I've opted to only require the substrate, just because if I want to search later for all the recipes that etched a certain substrate, I want them all to appear. But other than that, it's sort of freeform. The name, just be an example name. You can put a description here or wait till later. That's totally fine. The other options are, while you're at the tool, you can create a template, though I find this to be time-consuming. I'd rather have done it outside of the clean room via the web interface. And if you're uploading many data sets, so taking many SEM images of a handful of samples, you can just load the previous data that you had so you don't have to type everything again in the template. Just create the data set here. And the last step is drag and drop. So I'll just drag a random image to show you how it works, and this one actually has a rough surface, so I'll make a comment about it and then submit. And then our files have been uploaded to the ForeSeed database. So after we've uploaded, it would be useful to kind of see what everything looks like outside the lab back in the web interface. So if we go back to ForeSeed, I'm going to go to my dashboard where we see all of everything that I've uploaded. Again, I like the tree view the best. And we did a test root collection. And this is the data set that we just uploaded. So if I click on it, here's the picture. This is a TIFF file, so not proprietary, and also no metadata attached in terms of camera settings from the SEM. But there is definitely metadata that I had showed you in the template. This is the deposition tool that we use. We use a Trion, and then the handful of gases and gas flows, pressure, time, power, that sort of thing. Now, I promised I would talk about spaces and how to share data and to control who has access to your data. So here we see that we have our data set is contained in this space, the test space for DIBBS demo. We can add a space here if we already have them. So you can share the same data with multiple spaces. You can copy the data set to a different space. And the reason you might want to do this is to keep the raw data sort of unchanged. And if you copy it somewhere and then do some post-processing technique or run some MATLAB scripts on it, then you haven't actually altered the original data. It's sort of a safer way to do that and keep track of the provenance of your data. And this is just a list of the collections that contain it. Same story where you can add multiple collections if you want. Now, the space specifically, if we go to it, we can manage users here. And so far, this is just me as the administrator. We can add various roles for people. We'll add people to various roles. Admin has full control. Editor has full control through the web interface. Uploader, it means you can only upload to this space. This might be very useful if you have staff-assisted experiments that you would just like the staff to be able to dump your data sort of to the cloud so that you can see it. This is a perfect role for that. And viewer is exactly what it sounds like. It's read-only. So maybe your advisor or someone using your data as kind of a teaching metric might want to be only a viewer so they can't actually change the basic data. But to select users here, these are the users of 4Seed currently. So I'll pick on Patrick and add him as an editor and submit. And he's been sent then an invite here so that he can accept. If he already has a DIBBS account, he can simply just accept via email. If he doesn't have a DIBBS account, he'll be invited to make one for 4Seed, and then he can edit this space. In addition to the standard uploader that we looked at, if you have a large backlog of data, which I did when we started using the software, I had 4 or 5 years worth of data that I wanted to put into 4Seed, we can do a zip upload. And this works exactly the same as the normal uploader. Do you want to put this in a shared space? No, this is my private data. And you can just drag and drop a zip file here. And now it will maintain the folder hierarchy that you already have. So if you've zipped up whole project data and it has 50 nested folders, that's no problem. And we've uploaded up to, I think, 15 gig at once, and it works perfectly fine. The only caveat to all of that is, like I mentioned, in 4Seed's folder hierarchy, only data sets can hold files. So if you have many nested folders and at each level in the hierarchy you have sort of random files, maybe random text files describing what happened, something like this, then those will be automatically put inside of a data set that has the same name at that level. But that's the only change that would happen to your zip uploaded files, and then they become just the same as the things that we use a normal uploader for. So you can share them from there, you can edit them from there, you can give descriptions or tag metadata. So for me, the largest selling point of this software, I think, is twofold. The first is the obvious ease of sharing of the data with my group members, with my advisors, with collaborators on sort of large grants. And also at the same time, I can put the data in a place that isn't shared also. So something like Box or Dropbox, I have to share the whole folder, and if I want to have part of the folder private and part of the folder public, I need copies of the data, and then it becomes a version management problem that I don't particularly like dealing with. And in this way, I can just sort of, I want to include this data in this space, and I can share it with someone, but the rest of that folder is totally hidden, and that's from my own process development. And the next aspect that I think is really unique is the ability to preview files that are from proprietary file formats. So I don't have a copy of Digital Micrograph. It costs an incredible amount of money to have one, or I have to use a cracked one. And I think that it's much better to just be able to save those sorts of files that keep all of the instrument metadata complete, and I can still preview the images that I would get from them and treat those previews like they are actual JPEG or TIFF images. So for me, the largest selling point of this software, I think, is twofold. The first is the obvious ease of sharing of the data with my group members, with my advisors, with collaborators on sort of large grants. And also at the same time, I can put the data in a place that isn't shared also. So something like Box or Dropbox, I have to share the whole folder, and if I want to have part of the folder private and part of the folder public, I need copies of the data, and then it becomes a version management problem that I don't particularly like dealing with. And in this way, I can just sort of, I want to include this data in this space, and I can share it with someone, but the rest of that folder is totally hidden, and that's from my own process development. And the next aspect that I think is really unique is the ability to preview files that are from proprietary file formats. So I don't have a copy of Digital Micrograph. It costs an incredible amount of money to have one, or I have to use a cracked one. And I think that it's much better to just be able to save those sorts of files that keep all of the instrument metadata complete, and I can still preview the images that I would get from them and treat those previews like they are actual JPEG or TIFF images. So for more information about Foreseed, or if you have any other questions, there's very nice help documentation. So if you go to Help Docs, there's FAQ for both the uploader and the curator that sort of explains the file hierarchy. It explains how to upload information and what metadata is and how to preserve it. And also, if you're looking to deploy your own instance, it will also walk you through that. In addition, in the help page, there's a demo, which is a slightly more in-depth version of everything that I just showed you that works here. And then also just that same docs page.